Hello everyone, this is Nepalidi sir from ANR Academy. Let us learn how to find submultiple angles for trigonometric ratios like tan 22 and half or tan 9 degrees and tan 7 and half degrees like that. Usually the students follows the formula to calculate such type of questions. They follow that tan 2a formula they follow in general, that is tan of 2a equal to 2 tan a divided by 1 minus tan square a. Using this you can find tan 22 and half result, but it is very difficult to solve this. It will take more time. See, let us suppose if the angle A equal to 22 and half degrees, then what happens in the left hand side, it become multiple 2, so that 22 and half multiplied by 2 gives tan 45 degrees. Next, in the numerator part, you have 2 tan A divided by 1 minus tan square A, so that here we get 2 tan 22 and half degrees whole divided by 1 minus tan square 22 and half degrees. Here you need to find 22 and half degrees. Assume that as result some t. Wherever tan 22 and half is there, I am going to substitute that as t. You know that tan 45 degrees value 1 and tan 22 and half, that is selection t, divided by 1 minus t square it is. On cross multiplication we get 1 minus t square equal to 2t, so that we get t square plus 2t minus 1 equal to 0. So that here you got a second degree equation. It is in terms of t, where required value t, that is tan 22 and half. Yes. So on solving this we get the value of t with the help of the formula minus b plus or minus root over b square minus 4ac divided by 2a. You can find the value of t. The value of t become, here observe, a value 1, b value 2, c value minus 1. Substituting in that, minus b nothing but minus 2 plus or minus root over b square value 4 minus 4 multiplied by a into c, that is minus 1, 1 into minus 1 whole divided by 2 times of 1. It implies the value of t become minus 2 plus or minus, this is root over 8. Root over 8 value written as 2 root 2. So 2 root 2 divided by 2. There are two values, one with plus sign in the middle and the other with negative sign. But here the angle is acute angle, so that the result must be positive. So to get positive result, I am going to write minus 2 plus root 2 divided by, this is 2 root 2, not root 2, divided by 2. After division it become root 2 minus 1. So you got the value of t, that is root 2 minus 1. This is tan 22 and half degrees value. But it is very lengthy method. Suppose that if you write this formula, tan a equal to cosecant 2a minus cot 2a. With the help of this, directly you will get the result without doing all these second degree equation and its solution. In a simple way, within one step you will get the result. Now assume that a equal to 45 degrees. Sorry, a 22 and half you have to write. Automatically in the right part, what we get? Cosec 45 degrees minus cot 45 degrees, and hence you know that cosecant 45 degrees value root 2 and cot 45 degrees value 1. So directly you got this result, tan 22 and half equal to root 2 minus 1. So remember that when you need to find submultiple angles like 22 and half, 18 degrees or 7 and half degrees, for such angles this is not suitable formula. You need to follow this result, that is tan A equal to cosec 2A minus cot 2A. Using this you can simply get the result. And one more question we are going to discuss. See, suppose the question is find the value of tan 7 and half degrees. Suppose this is the question. No need to follow the formula tan 2A equal to 2 tan A by 1 minus tan square A. Just now we discussed, it is easily solvable by the formula tan A equal to cosec 2A minus cot 2A. Using this, see the result. Now tan of 7 and half degrees become, this is cosecant 15 degrees and this one cot 15 degrees. In the next step I can write tan 7 and half degrees equal to cosecant 15 degrees value, that is 1 by sine 15 degrees. Next this is cos 15 degrees divided by sine 15 degrees. In the next step I can write tan 7 and half degrees equal to, you know that sine 15 degrees value equal to root 3 minus 1 by 2 root 2. Reciprocal of this 2 root 2 divided by root 3 minus 1. Next, we know that sine 15 degrees value root 3 minus 1 by 2 root 2, but cos 15 degrees value root 3 plus 1 by 2 root 2. So on division we get, this is root 3 plus 1 and here root 3 minus 1. For both cos 15 degrees and sine 15 degrees, in the denominator part 2 root 2 gets cancelled and only we get root 3 plus 1 by root 3 minus 1 as the result. Since it has common denominator part, now I can write tan 7 and half degrees equal to, this is 2 root 2 minus root 3 minus 1 whole divided by root 3 minus 1. In the next step I am going to rationalize this, that is multiply and divide with root 3 plus 1. What happens, in the denominator part it become 2, so that I can write tan 7 and half degrees equal to denominator part 2, so that 1 by 2 taken outside. Now you have to multiply these two. 2 root 2 multiplied by root 3, that is 2 root 6. 2 root 2 multiplied by 1, that is 2 root 2. Next, minus root 3 multiplied by root 3 become 3. Minus root 3 multiplied by 1, minus root 3. Next, minus 1 multiplied by root 3, minus root 3, and then minus 1 multiplied by plus 1 gives minus 1. In the next step we get tan of 7 and half degrees equal to, here you have 2 root 6 divided by 2, that become root 6. Next you have minus 2 root 3 divided by 2, that is minus root 3. Next, 2 root 2 divided by 2 become plus root 2, and next minus 3 minus 1, that is minus 4 divided by 2, that is minus 2. So also you can remember like this, tan 7.5 degrees equal to root 6, 2 written as minus root 4, next minus root 3 plus root 2. So this is the value of tan 7.5 degrees. You got the result root 6, next minus root 4 minus root 3 plus root 2. So this is the way of calculating trigonometric ratios of submultiple angles, and students must be remember the formula when you have submultiple angles. This is the easiest method to solve such type of questions. Thank you so much.